So we are live, sir. Very good morning to all. It's my immense pleasure to welcome you all for the Knowledge 4.0 webinar series, which is one of the unique initiative of our chairman, Mr. P. Sriram, a successful entrepreneur, a first generation entrepreneur, and managing director of MK Group of Companies. So under Knowledge 4.0, we are conducting a lot of webinars in a serious manner, which includes technical webinar series, research webinar series, innovation webinar series, and career guidance webinar series. Chennai Institute of Technology was established in the year 2010 by our Honorable Chairman, Mr. P. Sriram. Now we are at the top 10 positions among all the private engineering colleges in Tamil Nadu. Within a short span of 10 years, we could be able to achieve this award only because of Chairman's dedication and involvement and all the faculty members' involvement in this journey. Today we have a technical webinar in scopes and opportunities in HVAC by Dr. RVSS Prasad. It's my happy and pleasure to welcome Dr. Sir. A few words about Dr. Prasad. Dr. Prasad is an engineer, MBA and PhD, and an expert in operation management, Lean, Six Sigma, and theory of constraints. He is a Six Sigma black belt holder, received his PMP certification a decade ago. He has over 30 years of experience in companies like Voltas, iGate, Barry Wemler, and Pawan Engineering, with expertise in HVAC, management, Six Sigma, and ERP implementations. He is a visiting faculty at premier B schools such as University of Hyderabad, JNTU Hyderabad, and NMIMS. He published many papers in peer-reviewed journals on integrating Six Sigma and TOC, orthogonal array techniques, and other topics. He guided teams to implement ERP solutions across different parts of the globe, including material management, capacity planning, and other modules. He is an adept trainer who can quickly adopt and provide practical solutions. Prasad is well versed in manufacturing methods and process and uses his knowledge to deliver programs in Six Sigma and Lean management. We cordially welcome Dr. Prasad for this session, and over to you.
Thank you very much, sir, for the very nice and kind introduction. I will just start with my presentation. I will share it, sir.
Perfect, sir. You can go ahead.
I'll just introduce EmergWay Academy as well. EmergWay Academy is a company founded by a group of experienced professionals. We impact on individuals' capability throughout their career by the power of training. Work extensively with engineering colleges, providing students application-based training in addition to helping them find chosen careers. Our flagship programs are aimed at grooming engineering and management graduates to be future leaders. So that's what we keep doing. And I urge you to visit our website for the latest information. So as the time is limited for us regarding the air conditioning systems, so what I thought of doing is first 45 minutes, we'll discuss briefly about the air conditioning industry, what is its future, what are the career options in air conditioning, then look at a few basics of fundamentals of air conditioning, and practically some applications of air conditioning system and their components, and then leave the last 15 minutes for question and answer sessions so that we can answer as many questions as possible to make it more interactive session. Kindly add your questions in the question and answers chat box so that we can look at the answers. Right. Is my screen visible, sir?
The screen is visible, sir, but you need to convert that into a slideshow view.
Yeah. Now is it?
Yes, perfect, sir.
I always start with one statement, I am an eternal learner. I don't love studying. I hate studying. I like learning. Learning is beautiful. Make learning a habit. Nobody can teach you. You only have to learn. That is the simple thought process that I have learned quite early in my life, and I'm still continuing it even after about 40 years of experience. So my sincere request to all the young students, all the future generation here, keep learning, keep learning. I just want to give brief about the industry called HVAC and R. I take a slide from Ishrae, Indian Society for Heating, Refrigeration and Air Conditioning Engineers. Incidentally, I am a president-elect for Ishrae as well, Indian Society for Heating, Refrigeration and Air Conditioning Engineers. This is a society which is formed to ensure that the air conditioning knowledge is enhanced and it is shared with as many people across India as possible. We have about 35,000 plus members, both students and the professionals, currently with Ishrae, and we conduct several programs for Ishrae. According to a survey done by HVAC and our industry by Ishrae, I'm sharing a few slides from that survey. Central air conditioning is, we can divide air conditioning into air conditioning and refrigeration. Actually, heating, ventilation, air conditioning and refrigeration. HVAC and R stands for that. Heating, ventilation, air conditioning and refrigeration. So this industry is one of the fastest growing industry and ever growing industry. This is important for the people to remember it. Ever increasing demand for air conditioning and refrigeration. We divide it into a few segments, the entire industry. We can divide it into central air conditioning, package air conditioning, VRF systems, room air conditioners, and cold chains. So as you know, room air conditioners form the biggest chunk of the whole thing in terms of the volumes, but others are equally important. Central air conditioning system, today it is catering to all infrastructure projects, IT, ITES, office complexes, retail, healthcare, hospitality, banking, manufacturing, your educational institutions, call whatever it is, you have central air conditioning system with chilled water systems. Then we have package air conditioners. All retail, small and medium enterprises, commercial establishments use this package air conditioners. VRF systems, fastest growing segment in the last 1 decade, I would say. It is also very, very similar to a DX system, but slightly advanced system in the technology wise, that is the latest technology I can say. This is used for multi-storied residential buildings, office buildings, hotels, restaurants, and the gyms, Zumba centers, all these things, VRF is used very extensively. Where chilled water system is not convenient, people are using the VRF systems. Room air conditioners, I think we don't need to talk about it because you know very well how you are using it. Cold chain products and systems. This is cold storages, refrigeration system basically. We use it in agriculture, ice cream, hospitality, supermarket, processed foods. You will be surprised to know that the whole world, India is the second largest cold storage users in the world. And we still have a huge demand for cold storages. Now look at the Indian market size by value. It is about $4 billion US dollars, $4 billion US dollars. And look at the graph, it is continuously growing. And the next 10 years graph also is, the projection is in a very, very similar lines. Particularly with the kind of environment damage that we have been doing, I'm sure more and more people will go for air conditioning systems, not just for the comfort, temperature and humidity, but also for the air purity. So Indian population is about 1.25 billions, out of which it is 17.5% of the total global population. What is the HVAC market? Out of it, only 2.8% of the global market. So there is a huge potential with respect to the market demand. And I can say, from being an engineer, being an entrepreneur, being in the industry for quite a long time, I can tell you we lack good engineers. We lack people with good technical skills. We are looking for the young generation to join us more and more. As you are all aware, most of the young generation in the last 10 years have moved towards IT because of the potential difference there. However, now the tides are changing. More and more people are interested towards engineering now. The core engineering fields, mechanical, electrical, and electronics, they are coming back, and we also see a surge of growth in terms of people joining us at the entry level. Now look at the energy consumption. From the energy consumption point of view, in any commercial building, if you see it, it is around 48% to 50% of the energy is consumed by air conditioning systems. So it's a big energy guzzler. So there is a lot of scope for energy conservation, and it's HVAC is now no more a luxury. It is a necessity. Yes, about 10-15 years back, people considered it as a luxury, but I'm sure you all agree with me that it is a necessity today and not a luxury. But unfortunately, even today, in many of the educational institutions, air conditioning or AC under is still taught as an optional subject, not as a regular core subject. I strongly recommend the institutions to start rethinking about this, because once upon a time it was treated as a service along with any other services, mechanical services like lifts or AC systems or plumbing and things like that. But today, everyone is aware that most of the power consumption is because of air conditioning systems. Most of the buildings are, by almost 99% today building are with air conditioning system. Hello. Yeah, global impact. 8% growth on electricity.
Sorry, sir. Sorry for the inconvenience. Actually, someone has joined using this link.
Yeah, I'm Caesar here, joined.
Sir, Caesar, I sent you another link.
Okay. Sorry.
Never mind. Can I go ahead?
No, sir. He has to leave the room. Otherwise, there will be audio disturbance.
Can you just do that?
1 second, sir. Shall I close the screen, sir, after you open the Prasad, sir, now you can share the screen, sir. Prasad, sir?
Yeah, I'm sharing.
Yes, share the screen.
Yeah. So now let us look at the energy scenario. About 48% of the energy is consumed in any commercial building by air conditioning systems, and that itself tells you that there is a lot of importance that air conditioning systems have to be given, and we have to conserve energy. And there is a lot of scope, and I would say air conditioning systems is both an art and science. Science in terms of the thermodynamics, science in terms of the heat transfer, science in terms of a lot of electrical subjects, motors and other things that we talk about. But the art is, how to design a system that meets the comfort conditions, that meets the commercial requirements of the customer, and that meets the energy requirements of the organization, and that also helps global warming impact. So it is an art. You need to work with a lot of other players when during the air conditioning system design, erection, installation, and so on. So it's basically an art, and that art you can develop when you are in the industry. What are the potential industries or roles that you can look for? Once you are have a little bit of knowledge about air conditioning system, and particularly the heat transfer, the thermodynamics, and the related things, you can go and join any HVAC and or manufacturers. Not only the main chillers or the equipment manufacturer, there are so many auxiliary equipment that are manufactured and required for making the complete system. As we go along, I will show you a lot of systems that are important to make this air conditioning complete. So a lot of auxiliary equipment, a lot of technology improvement has taken place in this. So there is a huge requirement of the ancillaries along with the air conditioning system, and those you can join anywhere along with any of them. There are contractors and dealers. Contractors basically execute the air conditioning systems, they design the systems and ensure that whatever is designed is executed, installed, and worked along with to give it a complete air conditioning system. Similarly, you have consultants. These are the people who are experts in providing the solutions for different applications, different requirements. I would say, please remember, air conditioning of a theater, movie theater, is not same as air conditioning of an operation theater. These two, though the theater is common, the operation that happens is very different, and the design of the air conditioning systems in each of these is quite different. Similarly, air conditioning systems, from application to application, the design is very different, and you need to be very, very clear about what are the key parameters that you are engaging during the design. So consultants play a major role, and again, I would say that there is a huge shortage of good consultants who are able to provide solutions, and I would like to see some of the people who are listening now to become good consultants in the near future. Now the size of the projects have grown up. Now almost, if you look at any air conditioning, small air conditioning project, it costs anywhere between 30 lakhs to 30 crores. So the project management becomes one of the more critical areas, and for project management you need to have both the domain knowledge, the technical knowledge, the managerial capabilities, and the ability to convince others and get work done from other people. So there are a lot of PMCs, project management companies, that are available today. They are doing a great job in ensuring that the projects are completed on time. So there is a huge opportunity there as well. In addition to this, there are so many other opportunities. You can become entrepreneurs and do a wonderful job and contribute a lot. It's a multidisciplinary field, as you are all aware. No engineering is individual today. It is a technology. So we are all technocrats. So there is multidisciplinary requirement for every engineering role. So though it is mechanical engineering dominated, I would say that it is a lot of other disciplines also play an important role, particularly the information technology, the material science, the instrumentation, environmental engineering, electrical engineering, electronics engineering, IoT, controls, whatnot. It's such a beautiful thing. It's exciting actually to know that you are in a multidisciplinary field. And most importantly, you are not doing something like a maintenance, like there is already some code which is already there, and you are only going and attending to a ticket. Here you are using your engineering knowledge that you have learned and showcase your brilliance in engineering, and even at the age of 50 or 55, after 30 years or 40 years of continuing in this field, you can still use your technical knowledge. That is the beauty of air conditioning engineering. And in fact, I learned more of electrical engineering, instrumentation engineering, material science, electronics, IT, all during my 30 years of experience in air conditioning systems. So HVAC provides a good field in which you can effectively use your engineering learning, witness consistent career growth. It provides entrepreneurship opportunities in various streams. It's one of the fastest growing and I would say ever growing industry, comparatively recession proof, offering multidisciplinary career opportunities. So please, I would request all of you to think about this and take this as one of the career options you can seriously look at. So as I said, what does HVAC and R mean? Heating, ventilation, air conditioning, and refrigeration. I don't need to discuss about what is heating, what is ventilation, and things like that. So I'm just going to the fundamentals of air conditioning. Air conditioning for comfort of people is controlling temperature, humidity. Is it the only things? No, there are much more. Airflow, air purity, and noise levels. Many people stop at temperature and humidity because that is when you feel that you achieved the comfort. But airflow plays a very, very important role. And air purity, now with the COVID and other things, you can always say that air purity has taken a different shape altogether. And noise level, of course, is very, very important to make people feel comfortable inside the air conditioning. So before I discuss about the basic refrigeration cycle, let us discuss about some fundamentals. Heat always flows from a higher temperature to a lower temperature. This is what is a science. When heat is flowing from a higher temperature to a lower temperature, during summer, the heat is more outside and we are trying to maintain a lower temperature inside. So basically what it is happening is the heat from outside, which is ambient, is flowing inside the room, which is expected to be maintained at a lower temperature. So how do you maintain this? This is against the basic law. So when you have to go against the law, you have to do something called an external energy, external force or external work you need to do to remove the heat from a lower temperature level and then remove that heat and throw it to a higher temperature level. So how do we do it? Imagine now you have a well half filled with water. You have to take a bucket of water from the well and fill it in a tub which is at the ground level. So water is at the lower level and the tub is at the higher level. So water also cannot flow from a lower level to a higher level. So how do you do it? You use a bucket, then you use a pulley mechanism, put the bucket and using a rope and pull that. So that means you are doing some external work, pull it, the filled water bucket, and then again using it, taking it to a level higher than the bucket, the tub on the ground, you are then pouring it into the tub. So that means you are first sending it to the lower level of water and then taking it to the higher level beyond the tub and then throwing it, which means that in a similar way what we are doing in an air conditioning system is also very similar. Basically you are removing the heat from the evaporator, which is in B, you can see it in B, the heat from the evaporator which is at a lower temperature, the refrigerant is at a low pressure liquid, and that becomes absorbing the heat, it becomes a superheated vapor. Now that is getting compressed, in a compressor at C. Now what is happening? Now that heat has to be removed or rejected to the atmosphere, which is it is done in the condenser. So you remove that, you take it to a temperature higher than the ambient, you take it to the pressure higher than the ambient. Then what happens? The hot gas will take it using the latent heat process. It will remove it and becomes a liquid again. but the liquid is still at high pressure. Unless the liquid is again brought to a lower level, low pressure, it will not be able to remove the heat from the lower temperature. So that is now done using expansion valve or throttling valve or automatic expansion valve or electronic expansion valve, whatever you call it, it does that. And then, the low pressure, low temperature the refrigerant again is going into the evaporator. So if you really look at both evaporator as well as condenser, these two are heat exchangers, where using the latent heat process, you either add heat or remove heat, and the compressor is here to change the pressure levels to ensure that maximum heat is drawn and rejected at respectively at evaporator and condenser. So this is in brief, the refrigeration cycle, and everything else, is a simple extension or application of this principle. Now, I think this is what, you guys see it every day. Particularly the mechanical engineering students, pressure enthalpy drawing, you see it. So you have a liquid phase before here on the left hand side, and the right you have a gaseous phase, and in between the curve you have a phase which is converting from liquid to a gaseous phase. So why do we need to go for a liquid to gaseous phase? Why not sensible heat process? Why we have to use the latent heat? So the answer is this: the latent heat process for a given volume absorbs more heat or rejects more heat. That's why we use the latent heat process. And one more thing is, it is a continuous process that we are talking about. It is not just an intermittent process where you just take it and throw it out. It is a continuous process that we are talking about. So we use the latent heat process. So we use the refrigerant that can do the work from it. And the refrigerant changes phase from liquid to gaseous state very continuously, and thus providing us the required air conditioning comfort. Now, let us look at air conditioning system with a water cooled chiller. That means you have a secondary refrigerant system. What it means is you are cooling the water from 12 degrees C to 7 degrees C in the chiller, and water at that 7 degrees C is used to cool the room. So the water at 7 degrees C is sent to the air handling unit, and that air handling unit coil will have the water, chilled water, and there is a fan in the air handling unit. Now, when the supply air after going through the coil enters the room at 55 degrees F, then it gets into the conditioned space, gets cooled to around 75 degree F, which is around 24 degrees C, and that air is again is getting mixed with the outside fresh air, which is almost around 36 degrees C or 40 degrees C, and that air again goes through the air handling unit, comes through the system at 16 degrees C, and this is a loop of the air that continues. And because the air is coming back at 24 degrees C or 75 degree F and getting mixed with this, the heat is now removed by the chilled water, which is at 7 degrees C, and then that chilled water goes at 12 degrees C or 53 degree F, and this cycle is a continuous cycle. So you have an air cycle, you have a chilled water cycle, you have a refrigerant cycle here happening. Now there is another cycle which you are seeing here, the cooling tower cycle, which is a condenser cycle. So condenser water, that means a condenser heat has to be rejected to atmosphere. So there is another cycle called cooling tower cycle. So there are, it's all about heat exchange. Simply saying there is multiple layers of heat exchange that is happening from room to room, the chilled water, from the chilled water to the refrigerant, from the refrigerant to the condenser, from the condenser to the cooling tower. So there are different layers of heat transfer that is happening. Now, heating, cooling, you are aware, humidifying is the process of adding water vapor to the air and to the conditioned space for the purpose of raising or maintaining the moisture content. Dehumidifying means removing the water vapor. See, remember this very fundamental thing. Whenever you are talking about air has got two principles mainly. One is the temperature and another is the humidity. That means the moisture content, the heat content and the moisture content. The moisture content is because of the water presence in that, and it adds the humidity. And in places like Jaipur or Rajasthan, where the desert, you have the very low level of moisture, and whereas in places like Chennai or any relate near to the sea coast or river side, you have the higher humidity level because the air has more moisture to it. So these two to be treated differently, and that is what I said. It is air conditioning is an art. Air is, because air is not the same all around. Air is different. It has got a different heat outside, and inside you have to maintain different things. So air conditioning is one of the most beautiful designs you can ever do it. Cleaning is, the cleanliness of air is one of the most important points, and I don't need to explain more about it, because we have been going through that seeing that in the last 3 to 4 months, thanks to COVID-19. We are all cautious about what we breathe. So in the process of removing particulates, dust, or ecological things, or biological contaminants, insects, pollen, or from the air delivered to the conditioned space, or for the purpose of improving or maintaining the air quality. Ventilation, the process of exchanging the air between outdoor air and the conditioned space for the purpose of diluting the gases contaminants. See, if you continuously breathe the air inside, then it leads to carbon dioxide and carbon monoxide increase inside the room. So continuously we need to add fresh air, depending upon the type of the application, the number of air changes per hour, or number of times the air need to be added, also is decided by the science. And Ishrae and Ashrae have got the standards for different applications of number of air changes. That is already there. So that is actually the ventilation. Now, air movement is the process of circulating and mixing air through the conditioned spaces. So you have to ensure that the air movement is proper and it is across all the space that is to be conditioned. Dew point temperature, you're all aware of it, the temperature at which the water vapor in the conditioned air changes phase to liquid. So the sensible heat is only when there is only change in temperature and no change in the phase. Latent haste when there is only change in the phase and no change in the temperature. Wonderful. Well, now we look at classification of AC systems. As I said earlier, AC systems we can classify mainly based on the type of air conditioning system that we are providing. We can divide it into two types. One is the chilled water system and another is DX system. DX means direct expansion system. Direct expansion system is where the refrigerant is going through the coil inside the room where air conditioning need to be done, and it takes away directly the heat from the room or from the air and inside the room. That is direct expansion system. Whereas chilled water system is, for example, you have a huge hotel or auditorium and there are so many places inside. So you have multiple air handling units working. So you use the chilled water to supply for taking care of different requirements in different rooms, and that chilled water is cooled by an air conditioning system or the chiller. So that is the chilled water system. So these two are slightly different in terms of how the refrigerant is used. You have a secondary refrigerant used in chilled water system, and you have only one refrigerant used in the direct expansion system. So earlier we used to have windows, plate and rooftop package units come under direct expansion system, and we had difficulty in connecting multiple indoor units with the outdoor units. So which is now overcome using the VRF systems. The technology is variable refrigeration volume or variable refrigerant frequency, VRF. So both are same, and we use that technology now to use to overcome the difficulties of both chilled water system as well as the window air conditioners. So these are more effective and efficient in terms of giving you higher energy ratio. That is why they have become more and more popular. Now, evaporative cooling, this is another area, but unfortunately we can cool only up to the wet bulb temperature. So that means they are not very useful in coastal areas and other areas where already you have humidity. You have so this is uses a principle of air getting cooled using by evaporating, absorbing the moisture and getting evaporated, and that giving the cooling. So that is what if you use earthen pots in the villages. Earlier days we used to have for storing water, our cool storages, our cooling towers that we have. All these use the evaporative cooling methods. So now to improve further, there are 2-stage evaporative coolers and 3-stage evaporative coolers, which can help you to reduce the temperature inside the room or maintain inside the room less than the wet bulb temperature as well. But still they have got their own limitations, particularly during the monsoon and other times. So they are not a direct replacement for air conditioning systems, but definitely very useful in terms of in large factories where there is more sensible heat which is getting heated up, and there you can use evaporative cooling systems. So this is again where do you use centralized air conditioning system, where do you use decentralized air conditioning systems? See, there is no hard and fast rule. Only thing is where you have more commercial requirements and the capacity requirements, you go for the central air conditioning systems. Where you need the redundancy, where you have standby equipment, you go for central air conditioning systems. Where no backup is required and where is very limited use, you go for decentralized system. Again, the cost of operation also becomes very, very important. The first cost, the operating cost, and the maintenance cost, or the total cost of ownership, I can call it. So that becomes very, very essential. Now, refrigerants, there are a lot of discussion happened, and very well that ozone depletion layer or ozone depletion potential, ODP. This became very important aspect for selecting a refrigerant. And one of the basic requirement is, the safety, toxicity, inflammability, effectiveness in terms of kilowatt per ton, lubricant oil miscibility, and compressor displacement. All these are the basic requirements of good refrigerant. So there are refrigerant now R123 which replaced R11, R134 which replaced R12, R404 which replaced R22, R507 which is an azeotropic and long-term alternative to R502. I'll take another 5 minutes and wind up quickly so that you can ask more and more questions, and we will leave it there. So as I said in the beginning, we have different components. This is supply air side air. We have about 5 different cycles. This is the first cycle of heat exchange happening between the air inside the room and the cooling coil. Then there is a second change, this in cooling coil and the evaporator, and the evaporator and the compressor and the condenser to again cooling tower, and cooling tower to outside air. So these are the different layers of heat exchange that is happening. Inside the room, if you see this is the conditioned space you have. You have the air handling unit, which is an evaporator unit basically. You have a coil, you have a fan, and you are getting fresh air from outside, and you are mixing the recirculated air. And you also have one more thing which is not shown here, which is an air filter. That is also very important, and the air filter plays an important role in defining or designing the size of the static of the fan that you want to use, because it has to overcome the filtration levels. So here is a coil. The coil will be chilled water in case of chilled water system. It will be a DX coil or the direct expansion coil in case it is a DX or a direct expansion system. So that this is an air handling unit, and that air is the chilled air is going to the conditioned space. The return air is collected back, getting recirculated. Some part is exhausted, some part is getting replaced, and you have fresh air that is getting added. So what are the different systems here? You have air distribution systems, ducts and to carry air, pipes to carry water, and also to carry refrigerant, copper pipe or steel pipe basically, and equipment to move air. You have filters, you have fans and other things, and heat transfer devices like air diffusers and tunnel units. These are made of either aluminum or GI or steel, depending upon the requirement. And operation devices like balls, dampers, safety devices, auto control, safety, and vibration attenuators, heating devices, electrical heaters. Oh my God, there is a number of auxiliary units that you are talking about here. The top level we are talking about is called high side equipment. High side equipment, we have chillers, VRF system, cooling towers, air handling units, fan coil units, or evaporator units. Well, chiller, cooling tower, pump, supply air fan, exhaust fan, fresh air fan, ducts, dehumidifier, controls, rooftop unit, chilled water, all these will be, you can see it. So if you see here, you have different chillers. This is a water cooled chiller. This is an air cooled chiller. Air cooled or water cooled is only because of the condensation or condenser purpose that we are talking about. Both are using the secondary refrigerant chilled water as the cooling systems. So this is what it is. The clear difference. Room air conditioning, room conditioning is done in a similar way. Only difference between air cooled and water cooled is at the condenser level. Please remember this, don't get confused. So you have pumps, you have different types of pumps, horizontal split casing pumps, vertical inline pumps, centrifugal pumps, end suction pumps, and so on and so forth. And the pump itself, you can take about 3 days session. VRF systems, beautiful systems. These are, they are very useful now because of the lower heights that we are getting now for the commercial spaces. So very useful to have different types of indoor units all connected to one outdoor unit. So they can use, different types of indoor units connected to multiple units, all controlled by electronics. It can be totally automatic. You can do it at the, using your remote at any place. So this is evaporative cooling system. There are 2-stage evaporating cooling systems. Insulation, there's so much of technology change that happened in the insulation and insulation material. We started with the thermocol, then fiberglass, then this is puff. We have nitrile rubber. We have n number of different types of material that are coming, and the ducts are made of just the puff itself. So very interesting. These days, again, insulation itself you can discuss for 2 days. Cooling towers, fan coil units, split units, variable air volumes. This is again used to save energy, suitable for hotels, restaurants, offices. Lot of technology that is going on here. So with this, I will just leave it at this point and stop for question and answers so that we can take more questions. Is that fine, sir?
Yes, sir. Yes, sir. We have almost more than 10 questions.
Go ahead, sir.
So we'll go one by one. And it was a wonderful session, first of all. And so I understand about my home AC much better now.
I still have about 50 slides, but because of the time constraint, I stopped at the basics, very basics, I could say. Not even basics, it did not go much. So we'll definitely have one more detailed session later on.
Sure, sir, sure. We'll arrange for that also, sir. So one of the questions is from, I think it's from a student. What will be the job opportunities post-COVID-19 in abroad in HVAC?
Whether it is abroad or whether it is in India, post-COVID, the opportunities have doubled. I repeat, opportunities have doubled because people are now treating air. Air treatment has become one of the most important things. And if you go to any places now, without doing the proper air filtration, air cleaning and other things, there is no space. So air conditioning requirements are going to be doubled, and it will be more and more opportunities available for the, I would use, for the right people. Right people in the sense they should have technology, they should have passion to work on this, and more than that, the inquisitiveness to learn and deliver.
You can switch on your video, sir, since it's going to be the question and answer session.
Okay. The inquisitiveness deliver is very, very important, sir. The attitude becomes one of the most important things. And that can come only when you love what you're doing.
Next, we have what experience should we have to undertake PMP certification?
PMP certification is basically, it is a project management professional that is given by pmi.org. Basically, you require about 3 to 4 years of management level work, and then 40 hours of training by PMI certified trainers and things like that. I would definitely advise it for the experienced people and not for the freshers.
Good, sir. So, any type of specific training required for HVAC and where it can be taken?
A wonderful question. This is, I think if you are clear about your thermodynamics, if you are clear about your heat transfer, I think that should be more than enough for an engineer to start his career or her career in air conditioning and refrigeration. Of course, there are subjects, which are there as optional subjects in the engineering currently. You can take them up. That should be more than enough. And Ishrae is, Ishrae student chapter. Ishrae has many student chapters across India. You can become a member of Ishrae student community, and then they offer a lot of training programs during the year. You can take any one of them. Ishrae also offers certification courses. You can always take them. There are other private training institutes which are there, and I am not sure about what is the quality of those things, but yes, there are private institutions as well giving training.
So next we have, what are your suggestions during this lockdown for the students using the ACs?
Either it is students or anybody, keep the temperature above 25 degrees C. Keep at least some fresh air entering inside the room, and keep your filters clean. That's enough.
So what is the suitable atmospheric condition to air cooler in case of AC?
I didn't understand the question, sir.
So what is the suitable atmospheric condition? I think he's asking about the temperature with which you can use the air cooler in place of AC, air conditioner.
See, basically, as I said earlier, it uses a principle called evaporative cooling. So evaporative cooling is, air absorbs moisture and then, it becomes cool. So that is how it works. So in places where the relative humidity is low, like, for example, we have in Hyderabad about the relative humidity in summer is around 20%. So which is available for the air, that 70% of that is available to absorb it and then, become saturated. So till it becomes saturated, you can always use that to remove heat from the room and use that evaporative cooling. So the lower the wet bulb temperature or the relative humidity, the better.
Fine. So during this COVID-19, the centralized AC need to be avoided?
No, not required. Not required. And I would encourage all of you to go to ishrae.org. There are guidelines given by Ishrae. There is a special team that has worked on the Ishrae on the guidelines for air conditioning systems. What are the things that you use, and you all of you can download it for free from the ishrae.org, ishrae.org. You can download the guidelines document, and you can happily go through and apply those principles. And to answer your question, we don't need to avoid air conditioning system.
Fine, sir. So again the same question. What is the room temperature that we need to maintain in any room?
Around 25 degrees C, more than 25 degrees C, around 50 to 60% RH is what is a good temperature and humidity condition that will help.
Okay. And then another question is like relations between HVAC and FACS technology, FACTS.
What is the technology, sir? FACS?
I don't know. That is a question posted by Mr. Mahesh Kumar.
So if I know what a little bit at least what is that technology, then I can.
Yeah, HVAC with FACTS, FACS technology. Okay. So we'll move on to the next question. Is it mandatory for ACs need to run for the whole night for household usages?
It depends on the individual who wants to use it like that. But if you set a thermostat for 25 degrees C, these days all compressors are are capable of turning on and off automatically, particularly the room air conditioners. And whenever the temperature sets it there, it will restart or change based on the temperature outside. It will either restart or not. You need only the evaporator fan running. Compressor need not run throughout the night.
Fine, sir. So is there any software courses on? Sorry.
Don't ever set the temperature less than 24 degrees C. At least during this period, don't set it.
Fine, sir. So another question, like any software courses on HVAC, like gas turbine cycles?
There are a lot of videos available on the YouTube. Okay. And when you say software, the only software we use for designing the system is the heat load form, which is again, very simple. We don't need much. So I don't recommend any software systems for this, but I would certainly recommend that, change your, style of thinking. We are like, creators. When you see air conditioning systems, that means, there is a room to be built. There is an entire area which is to be built. Construction is still not happened. It is only in the architectural drawings it is there. So you imagine that kind of a buildings, then you imagine what kind of people will be there, where they will be sitting, and you are designing air conditioning systems much ahead. So that itself will give you a kind of satisfaction once you design those systems. And again, as I told you, each system is different. Each one you decide is different. You decide air conditioning system for a hospital is different. Within the hospital also, for an operation theater it is different. For an ICU it is different. For a wards it is different, and things like that. And similarly, for air conditioning of your malls is different. So ventilation systems are different. Chilled water systems are different. Such a variety of designing opportunities you will not get anywhere in any industry. And if you have to have that flair, you have to have that flair to go to the sites, solve the practical problems. You may design something here, but when you go to the practically there, it is totally, quite a lot of things have changed already there. So you now need to, without having to change the basic core thing, you need to apply your science, you need to apply your engineering, and apply your commercial mind to ensure that, you get what you want. This is something beautiful. Software,
one more question.
Tool. Software is only a tool. You can develop many tools like that. What you need is this tool.
Rightly said, sir. Okay, so let's end up with the last question. So what type of customized training do you suggest for HVAC?
There are, air conditioning systems, there are different things, sir. Basically, you look at the air side, you look at the water side, you look at the refrigeration side. These are things. Similarly, you have insulation, you have hydraulics called pumps and this thing, and there are different things that you. So my recommendation is go through your engineering subjects clearly. Make your mind to take this as a career option and take up any one of these areas where you want to see and where you are strong in it. Particularly, suppose somebody may be strong in pumps and flow and those things, or somebody is very strong in air conditioning, or somebody is very strong in thermodynamics or heat exchangers. So you decide where you want to go for, and then work towards it. That's more than enough. You don't need to have a specific customized ones for the entrance or for the interview. You not really require. Again, I will leave you with one thought. When we come for interview, when we select people, I did interviews, for more than 1,000 people now during my last 10 years for various requirements. What we look for is, what is the basic knowledge and the ability to apply that knowledge is what we look for. What is the kind of attitude the person is having? We don't worry about your grammar, your English and other things. Those can always be understood. But what we require is, what is the attitude? What is your willingness to learn, willingness to learn new things? That's where
Perfectly said, sir. Like, attitude,
some noise from your side. Go ahead, sir. Some noise, but okay. Yeah, fine now. Not audible, sir. Not audible.
So is that clear now?
Yes, sir. Go ahead. Yeah. Go ahead, sir.
Sorry for the inconvenience. So to continue from Mr. Prasad's word, attitude plays a very major role in the interview process of mainly in the core company placements. So the students should have a very right attitude and the interest towards the learning. So that is more than enough for them to get placed in good core companies and to make his career a bright future. So thank you very much, Dr. Prasad sir, for making this wonderful and interesting session. And I thank all the participants for their patient listening. We had around 803 participants for this session. Now currently staying around 795. Thank you all. Wish you have a wonderful day ahead, and let's meet tomorrow for the next sessions. Thank you very much.
Thank you very much, sir. Thanks a lot.